Hello guys, welcome to Knowledge Base. In our previous video, we looked at two cases of two forces acting on an object in the same direction and in opposite direction. In this video, we are going to consider case 3 where two forces are acting at an angle of 90 degrees to each other on an object. We are going to look for the resultant force R, and we are also going to look for the direction of the resultant R. So the first thing we want to do is to calculate the magnitude of the resultant R. To do that, we are going to complete this triangle. We are going to complete this forces into a triangle by completing this side of the triangle. If this is 3 Newton, obviously this is 3 Newton because they are parallel, and the resultant is just somewhere in between the 3 Newton force and the 4 Newton force. Now we have a right angle triangle and we are looking for the value of R. So we can do that using Pythagoras theorem. And according to Pythagoras theorem, R squared is equals to 3 squared plus 4 squared. If we solve this on, R squared will be equals to 9 plus 16. 3 squared is 9, 4 squared is 16. So that R squared is equals to 25. To obtain R, the square would have to cross the equation sign, equal to sign, to form a square root and introduce a plus or minus, because R squared means R has two values. So R is equals to plus or minus the square root of 25. The square root of 25 is 5, so that R is equals to plus or minus 5. But we know that force cannot be a negative value, so minus 5 is invalid in this situation. So the correct answer is positive 5. So that R is equals to 5 Newton. 5 Newton is the magnitude of the resultant force. Now we want to look for the direction of the resultant R. To look for the direction, it is neither east, west, north, or south. It is somewhere in between north and east. So it is making an angle either to the north, which is the vertical, or to the east, which is the horizontal. Hence, we are going to introduce an angle theta, so that if we get the angle theta, we can use it to describe the direction of the resultant R. You can choose to put your theta here and find the value of theta at this point. Any one of them is just fine, but I chose to put the theta here to find the value of to find the direction of the resultant R. So if the theta is here, if we consider this triangle again, we'll find out that tan theta is equals to opposite 3 all over adjacent 4. So we can say tan theta equals to 3 all over 4. To obtain theta, we take the tan inverse of the other side, so that theta is equals to tan inverse of 0.75. 3 divided by 4 is 0.75. You call this tan inverse of 0.75, or you can say arctan 0.75. If you put this value into your calculator, tan inverse of 0.75, it will give you theta as 36.9 degrees. It means the angle here is 36.9 degrees. But you can't just put a value for the angle without mentioning what angle it is, because like I said, this could be your theta. You could find the angle theta here. You could also find the angle theta here, even though both will not be the same value, but you can't just give the value of theta as the angle, as the direction, without mentioning anything along with it. This theta is the angle arrow makes with the east or the horizontal. If you found your theta to be this point, it will be the angle it makes with the vertical. So I'm going to describe my direction as theta equals to 36.9 degrees to the horizontal. Theta 36.9 degrees to the horizontal. So if you found your angle here, your direction would have been whatever it is to the vertical. So this is the direction of the resultant vector, and 5 Newton is the magnitude of the resultant vector. If you understood this, then look at this. Please find the direction of the resultant in this diagram. Just the direction. We don't really care about the magnitude at this point or for this particular question. What we just need is the direction of the resultant. Thank you very much for watching. Share our videos and see you in our next video.